Have to be honest with you, I love this type of problem. The pressure of a gas is doubled while the volume is decreased to 1/4 the original volume. The initial temperature is 23 degrees Celsius. What is the new temperature in degrees Celsius? Oh, there's just so much good stuff going on here. Okay, so first off, the pressure changes. Okay, so we have a pressure change, we have a volume change, and we have a temperature change, which means that we're going to want to use the combined gas law. And the awesome thing about this problem is, calculation-wise, it's really, really easy. It's very fast. But thought-wise, well, you have to think a lot, which I like. So see if you can pause, figure this out, and then come back to it. Okay? So let's just take this piece by piece. The pressure of a gas is doubled, okay? So that means that P2 is going to be 2 P1, okay? Because the pressure of the gas is doubled. While the volume is decreased to 1/4 the original volume, which means V2 equals V1 over 4. Okay, and rather than having a fraction in here, I'm going to swap this to 4V2 equals V1. It doesn't really matter which way you use it. I'm just going to use this for simplicity's sake. Okay, now I'm trying to find T2. So I'm going to cross multiply, okay? So I'll get P1 V1 T2 times P2 V2 T1. I guess I'll just write that out. P1 V1 T2 equals P2 V2 T1. Okay, and then I'm going to divide, because I'm trying to isolate T2 by itself. I'm going to divide both sides by P1 V1. Okay, when I do that, P1s go away over here, V1s go away over here, and I'm left with T2 all by itself. So T2 equals P2 V2 T1 divided by P1 V1. All right, now I'm going to start plugging stuff in. Okay, so P2 is 2P1. So I'm going to substitute 2P1 into P2. Okay, V2 I'm going to leave because I'm going to substitute for V1. And T1, the initial temperature, is 23 degrees Celsius, which in Kelvin is 296.15 Kelvin, divided by P1 times V1, which I'm going to substitute in for 4V2. Okay, now hopefully you see what's coming here. V2 goes away, P1 goes away, and then this 2 over 4, this just simplifies to 1 over 2. So the only calculation that I end up having to do is 296.15 Kelvin divided by 2, which equals 148 Kelvin. Okay, and if I take that and I subtract minus 273.15 so I can get it in degrees Celsius, that's negative 125 degrees Celsius. Again, these are really good types of problems. They're very fast, very easy to set up, okay, but you actually have to think a little bit, and I'm a big fan of that.